Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Unit testing can be a challenge, especially when you have automated testing or maybe new to test-driven development. There are several great design patterns for testing and even more anti-patterns in unit testing that you want to avoid. In this episode, we're going to look at a few of the more common anti-patterns you will see when unit testing so that you know what you're dealing with and what to avoid. But before we get started, Will, what's been testing you this week?
Well, I think you heard some of that. When we got on the call, I was like troubleshooting a Docker Compose file and a few other things. And for some reason, I did not have all the configuration information that I set up when I did all this Docker stuff. I didn't have that down anywhere. And so like, I'm trying to reverse engineer this stuff. And I think you probably heard all the profanity that, when did I set that up?
Oh, yeah, that was funny.
Yeah, it's like, because when you're over 40, you learn to write this stuff down because like it eventually gets you, like, especially like if you're, if you were stressed out when you were setting it up or you've been stressed out since, memory's not maybe what you need it to be. So that was entertaining, but I do have a working install of Directus now on my NAS that is backed by Postgres that I can get to from my box, 30 feet away. So it's kind of cool. Don't know what I'm going to do with it exactly other than just play around, but that's something. Also, we went to see the Dune movie.
Oh, finally. What'd you think?
Yeah, it's good. It was very true to the book. I mean, there were a few things that I was like, they kind of left, a couple scenes out. Of course, some of the things were probably not as important for the overall storyline.
They left a lot of the intrigue out.
Yeah.
That's what I noticed. It was more action based, and it just kind of goes to show the style of movies that we have now. About 30, 40 years ago, there would have been a lot more of the intrigue involved in it.
But it was good. And it's like you said, the copters were kind of, or the thopters rather, were like I would expect.
Yeah, I know. I was really impressed by that.
Yeah. So yeah, overall, very good. Looking forward to the other ones. It's definitely far better than the more recent Star Wars.
Yes.
So yeah, I'm looking forward to that. I haven't looked forward to another movie in a series coming out since, I'm trying to think now,
Harry Potter.
Maybe Lord of the Rings.
Yeah.
It's been a long time. Yeah. How about you?
Dude, I had a PR fail today because the linter expected not equal, and I purposefully used not equal.
So you did type coercion.
So yeah, sometimes I think we overdo it with the automated checks.
Yeah, especially when you can't tell it to not take that one. Like that's the
yeah. Like I was doing that on purpose, and if I have a valid reason for doing something simple like that, I shouldn't get dinged for it.
Well, and of course it. Being in a JavaScript type environment, you can't really do like a pragma to say, "Hey, dog, leave me alone about this. I know what I'm doing."
Yeah,
I guess. So, I don't know. You might be able to do some kind of comment based something, but yeah, it's annoying. I've been bitten by that a few times as well. Not that one in particular, but
yeah. Well, I was talking with one of the other developers. And he's like, "Yeah, it's funny the things it will ding you on, and the things it won't."
Mm-hmm. So
yeah. Anyway. In better news, I had my one-on-one with my manager today, and my team likes me.
That's good.
Yeah, she said that she had gotten good reports from me, so I really do have a good team. I enjoy working with them. They're great group of people. So it has been a busy week. I was telling you about that earlier. Friday, we had men's night at church, which was a lot of fun. Axe throwing, cornhole, mini golf. And some game where you have this like hammer that kind of tapers down. You have to like hit a nail into a stump, and the first one to get it flush wins. You get one hit per round. It was a lot of fun. It was very challenging, but a lot of fun.
Sounds like that'd be
Uh,
a great drinking game.
oh, I'm sure. I'm sure. I think all of them would have been great drinking games, but it was a church event, so no drinking.
Yeah. Well, axe throwing that is a rather Viking drinking game, I guess.
Well, every axe throwing place I've ever been sold beer, so
There's that.
Anyway, yeah, it was a lot of fun. Then last night we're recording on a different night than normal because last night we had creative night at church, and I got to lead the creative activity, so that was really cool. We did some fun stuff with that. Also set it up to stream, so which was a fun challenge because we're not allowed to use the tech team equipment. So it was a blend of the creative team equipment and my personal equipment to get the stream to working. Though we did use the soundboard because, like there's worship involved, and so we have to use the soundboard for that. I just was not allowed to use. I've already asked about using the streaming equipment and was told no. So I was like, all right, well, I'll just use my own then. So that's what we did. But it was cool. It was cool. Tomorrow night I get to lead communion before our worship practice. So it's just been a lot going on. I'm just glad I've got the day off tomorrow. So because it's Veterans Day, so that's gonna be nice. I'm gonna sleep in. Maybe we'll see. Will's met me. He's like, yeah, you'll sleep in for 30 minutes and then you'll get up and be doing something.
Yeah.
So now my video announcements, I think I told you guys about recording those last week. They aired this past weekend. And I did a good enough job that they're letting me do it again.
There you go.
So that's cool. Also, I got to set up the lights and cameras for this week's recording all by myself. I can do it by myself. Now, though I did break one of the lights. Well, not the actual light. It was a little piece on it that like holds it onto the stand. Cheap plastic. That's all I'm saying. Like I tightened it on there and you don't feel it get tight and all of a sudden it just snapped. So yeah, that broke. Thankfully they weren't mad at me. They're like, that happens. It was cheap. So, but yeah, and we had a backup. I think they might have been upset if we didn't have a backup. But anyway.
Saving money is hard, especially when you break equipment at church.
That's good.
Sorry, man, I had to.
I know. That's good. Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at CDP, he focuses on helping you to not only establish a real plan that creates your best life, but to actually take action on that plan so that you get there.
Yeah. So, guys, investing in financial planning services, it really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding interest of making better financial decisions will easily pay for itself.
And Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And the best part is Lucas is a fiduciary for his clients. What that means is he's not here to sell a product to you, but he's here to guide your financial choices so that you make better financial decisions.
And you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face and interviews other techies who share how they navigated their careers. You can also learn more at levelupfinancialplanning.com.
Test-driven development, or TDD, is a paradigm where test cases are written based on stories or requirements before any coding is started. It can be difficult to kind of wrap your brain around the idea of writing tests first if you haven't developed it like that way before. Sometimes you don't know what you need to test until you've built it. Now, the idea with TDD is to start with the basic business requirements for testing and build to the test. Then, if anything else needs to be tested because it came up during the development process, you can write tests for that after.
Unit tests are test cases that are designed to test specific units of your code. unit tests are also code themselves, and so they require maintenance, and they have their own set of design patterns and anti patterns.
An anti pattern is an observed pattern of behavior, typically repeated, that is inefficient at best and directly harmful at worst. Anti patterns in unit tests are patterns seen throughout a test suite that may seem like a good way to do things, but in effect cause more damage than good.
In this episode, we're going to look at just a few of the more common anti patterns in unit testing. These are the ones that you're most likely to see as a developer and the ones that you're going to have to be most watchful for, but they're not the only ones.
Oh, yeah. Now, in the aftercast, we'll discuss some unit testing code smells that aren't quite anti patterns, but they're just things to look out for in your unit tests.
So, the first one, no structure when creating unit tests. Test code is also code, so you do have to structure it and be disciplined about it. The idea here is, again, that it has to be easily read and altered if you need to, which you're going to have to do as the rest of your code evolves. And if you don't have a structure to test code, it makes it harder to understand and to maintain.
Yeah. You're going to want an easy way for people to look at your tests, a consistent way too. I mean, that's not something I said in here, but you want consistency across your tests. Like if you want to try something new, start out like either in a new test suite or something like that. But like the tests in this particular set of unit tests, the test cases, keep them all the same. A simple structure for doing this is to organize the code into different stages of the testing process. The one I like to use, and probably the most common, is the arrange, act, assert. Though there are several different others. Another really popular one is the gherkin, given, when, then. But basically anything that breaks the code into sections based on what is happening in that code will work for a basic, simple structure for setting up your code.
The arrange or given stage is used to initialize any variables and dependencies of the things that you're testing. And this is where you do things like set up mocks, anything that is test specific. And depending on the framework you're using, some of those pieces, you have other options a little bit. So it's important to kind of discuss that. But
yeah, that is sort of framework specific. And if we were going into like how to build unit tests, that would be something we would talk about too. Which that's actually not a bad episode idea. So just saying. The act or when stage calls the unit of code, the method or the function you're actually testing. This is typically the smallest segment or section of the testing code. A lot of times it's just a single line calling it. Yeah.
I've seen some that have been pretty gnarly on that, and that's an anti-pattern we're going to discuss in a little bit. Finally, the assert or then stage verifies that the unit of code that was called actually did what you expected. It checks the outputs and verifies that calls to mocked dependencies, like repositories and those kind of things, actually happened and happened the way that you expected them to happen.
Yeah, because you can set it up in your arrange or given or setup stage to throw an error. And so you want to see how does your code respond to the repository throwing an error or the database throwing an error. And by doing that in the mock, you can then assert, okay, well, it's going to return this error code or that based on that. So it doesn't have to be just the happy path that you're asserting.
Yeah, in fact, that's honestly the best place for unit tests a lot of times is the unhappy path.
Yeah, and that's the thing. I see a lot of people who only write happy path unit tests.
Yeah, given the option, I would rather just write the bad ones. Like if I don't have time to write all of them.
Yeah. So the next anti-pattern is there is too much setup to run the test cases. This happens when tests require an excessive amount of setup just to be able to run. This may be in the arrange stage of the individual tests or in a separate setup method that runs before the test. It could be run before the test suite or before each individual test.
And I've seen this where there are hundreds or even closer to 1,000 lines of code just to set up, a test suite. And a lot of times that's, it's because it's testing too many things or because your other code's not factored well and has a lot of dependencies. And it really makes it extremely difficult to understand what's being tested because of all the extra crap that's going on. And troubleshooting is fun too.
Yeah. The only time I've seen it really there'd be a lot in the setup and it not be a problem is when you're mocking like an object.
Yeah, or you're mocking a lot of them.
Yeah. And you just have to be like, all right, well, got to fill in all the different properties for it.
Yeah, I've seen it where they've had a Fluent interface that they were setting up that was very complex. Like they were actually writing the unit tests for their Fluent interface, and so they have to like set up all these weird data conditions because that's what you're doing the work on, and they're doing it with the Fluent calls, and that I don't like the way that Fluent interfaces intersect with testing just in general. Like I really it makes me not want to use them.
That makes sense. Typically, this occurs because poor use of mocking or code that hasn't been built with testing in mind, resulting in the test being too tightly coupled to the implementation of the code. And basically, this makes the test brittle and just practically impossible to maintain because any change to the code is going to require a massive rewrite of just the setup to run the test. Like not even the tests themselves, just the setup of it.
Yeah, and it's never intuitive either. As far as like what did I break? When you have heavy mocking and stuff, it's like, oh, I just got a null here. I don't know why. Yeah, it hurts a lot. And speaking of things that hurt a lot, another thing that will get you is improper cleanup after tests have been run. So most of your test suites will either have a cleanup method that's run after each test or after all the tests have been run or some mix. Your code in this method will remove objects from memory, close files, those kind of things. Hopefully. Sometimes it doesn't happen.
Yeah. No. Improper cleanup occurs when the code that cleans up the mocks and anything created in the test is insufficient or just not there. I have seen it just not be there before. It may leave files open or objects in memory, causing memory leaks. I mean, it can get messy, especially if you don't have a good testing framework that kind of wraps it up too.
Yeah, my favorite is when they combine that with using statics all over the place. And so those things hang around and they affect the other tests because they're still there. Yeah, that's great. When it's like, oh, this test, it fails like 1 time out of 9. How do I prove that test is now passing? Like now I have to use statistics for something that ought to be binary. It's really ugly, really quick, and this will get you there. This can be really important if your tests are doing stuff like file manipulation or if you're creating files during the testing process.
So I had an issue with this when I was writing a file uploader. Basically, what was happening is they were scanning in documents, and I wrote a background app that just sort of sat there on the server and pulled the folders on the NAS. And whenever there were files in there, it pulled them, processed them, and uploaded them to long-term storage. Testing that was interesting because I had to have a file to test to see if, is it able to get the data out of it that it needs? So I had to create, like my test suite would create a folder and a file in the setup. And then in the cleanup, I had to delete the file and the folder. And if anything messed up during the process, I couldn't delete the folder if there was anything in there. So I had to delete everything in that folder. So I had to write my cleanup code so that if if something messed up in the testing process and the folder didn't get removed, that it would the next time around.
Yep. So you got to get it on both sides.
Mm-hmm. So that was a little tricky, but once I figured it out, it was like, that code was actually really useful, and I reused it in several other places where I was having to do stuff with file manipulation and test that, because once I had that, like those 2 code snippets, the create and the removal, it's like, hey, now that I've got this working, like I can set this up, and like even a little modification could set it up to work with automated testing on the cloud, or in the cloud.
and I guess you really couldn't use mocks because you're automating like file operations. Like it's not,
Yes.
I'm not dealing with an abstraction of the file system. It's like I'm literally touching the file system and at a lower level. And like you don't mock that because it doesn't, you're not testing anything if you do that. So been there, done that, not in that particular type of thing, but some fairly similar setups. Like back in the old days when people would FTP stuff in and you had to react to it.
Yeah,
Yeah.
it was definitely a lot of fun. I loved building that app, and then like I said, that test code I've reused that so many times whenever I've had to do file manipulation stuff, and even had some stuff like yeah, testing it in various environments. Yeah, it's been kind of cool.
Well, and the next point actually kind of fits with what you're talking about there, and that's where your tests depend on something that's outside of the test suite.
Yeah,
there are quite a few anti-patterns that come out of this because you're trying to isolate code. Like that's one of the pillars of unit testing. And obviously, if it's a pillar of something and it's not there, it falls over. And so this is a pretty common issue. And this typically occurs when there's something that the test needs to be able to run, but it's not mocked either because it wasn't possible to mock it or because somebody didn't think to mock it.
yeah.
Especially with older code bases, like the inability to mock something is definitely a real problem, or where they make it really nasty, like using statics all over the place in .NET, for instance. It's a great way to do that.
I've seen that. Yeah,
Yeah, I
I've
would
had to
put a
deal with.
service around it, around the static, and then mock the service.
There you go. That works. Yeah, I've had to deal with other people's code, newer code, recently written, like had been written a month or two ahead or before I had to deal with it. That was so full of statics that I'm like, all right, we're like two socks and a balloon here. So much
Yeah,
static.
yeah.
Sorry, I couldn't help it. Bad radio station. I don't know. Trying to find a joke that worked, but yeah. One specific anti-pattern occurs when the tests rely on an environment specific variable that may not exist outside of development. This could be anything from an authorization issue to a particular file on the developer's machine that is only used for testing. I actually ran into this recently with some API stuff where the repository tests were relying on certain authentication to talk to the database that like wasn't on my machine because I hadn't set up that environmental variable.
Yep.
And I was like, and so I went over and I tested the master branch and I'm like, all right, why are all these tests not passing? And they didn't pass on master either. I'm like, okay, now this doesn't make sense because for it to be on master, it had to have like run through. And this is when I first started working on the API side of this project. So like I hadn't touched the API yet. Or this is the first time I was touching it. And that's when I realized, oh, all the unit tests are categorized like as unit. And so the automated testing only runs the ones categorized as unit and does not run the repository ones because they're not. And I'm like, oh, that was smart. I'm impressed. Yeah.
Yeah. You're talking about the environment variables. I've seen it too, where somebody will, and this has been years because obviously once you do this once, you don't do it twice. Where the default for an environment variable was like the production settings, and you had to override it to do it in testing. And that's great when somebody points an integration test suite at production. Because guess what just happened? And the kind of people that do that obviously don't write very good tests either. So like they're all integration tests, even if they think they're unit tests.
Oh, of course. Of course they are.
That was a 3-hour database restore.
Fun.
Lots of yelling, not at me.
Oh, I'm sorry they weren't yelling at you, man. I know you
I was
enjoyed that.
quite amused and had to keep a straight face. It was great.
Yeah. Oh, yeah.
Yeah. And, one thing that will get you on this is like when you've got to have data there in the database to test as well, where the test doesn't run. And, if it's not mocked or populated in the arrange, stage, then finding out what is actually supposed to be there tends to require that developers start digging through code. And you'll see this a lot, like when somebody's, you see this with Entity Framework a lot, where people are like, okay, I'll use like SQLite or something and spin up
Mhm.
a database. And then they've got like some script that they load it with, but they didn't check that in. So you go to try to run the test, it doesn't work.
So I actually ran into this today. Now, I didn't cause the problem. One of the developers I work with ran into it. He was working on something, and he was like, "It works when I'm running it through Swagger, but the unit test keeps failing." And so we got in there and looked at it, and I realized it's basically mocking the same call, like is making the same call to the database that was mocked, but it was passing in different things, like to get stuff back. And so, well, actually to the repository, but anyway, it was, but it was returning the same thing because it was like, it is any, when you're doing setting up the test, because you don't only expect it to make one call there. And I was like, so I'd be like, hey, so this is why you're getting this null exception. It's not matching the same style. So what you need to do is, set it up so that you have two separate setup for that. Like one that when you pass in this value, and one when you pass in that value. Because now it's not just anything that gets passed in, it's specific, because we're using that in the actual method.
Gotcha.
Yeah. It was one of those things. It's literally like I didn't even think about it because I had written this before, and like I was helping with it when you just read that. I was like, I just saw this today.
Yeah. Well,
So
I was thinking,
and it
like,
wasn't it wasn't even an anti-pattern really. It was just like he was in the process of setting it up, and he's like, why is this not passing? And junior developer, he just didn't have the experience to know, oh, go look here.
right.
He's learning that literally. But yeah, smart guy. He picked it up really quickly. So once I pointed him in the right direction.
And speaking of going in the right direction or not, sneaking in refactors to test code while you're building new features, not ideal. Partially because, okay, well, you altered the test code. Now you're altering the thing under test. How do you figure out which one's wrong when it's wrong after this? Yeah. And I've done this too, right? Like you're in there and you're like, well, while I'm in here, I'm going to clean up this unit test code. You're building new features, whatever. And the thing about unit tests is you really need those to be stable when you're screwing around with the part that they're testing.
The best approach to refactoring your test code is to have a separate technical debt story or card or requirement or however you're set up, and dedicate specific time to the refactoring that allows you to completely focus on the tests and the code being tested.
Yeah. And I would also add to this that if you're going to alter unit tests in a situation where you're changing something, generally speaking, your operations should either be delete or add. You don't change a test. And that won't keep you out of trouble completely, but it is less likely to smack into something, I guess. So
yeah, that makes perfect sense.
Now, in reality, though, a lot of us don't really have the technical debt stories, so we do have to sneak in refactors as we go along, or the story can't, we can't get to that story quickly enough. If it's the case, try to do your refactoring either before you start work on the feature or do it after you have built and tested the feature.
That usually works. The key to this is to focus on one thing at a time. You're either building and testing new features or you're refactoring. Trying to do both at the same time is going to get overwhelming and lead to mistakes. And you really don't want mistakes in your test code.
Yeah. Saw one of those today where somebody wasn't testing what they thought they were testing, and there was a process that has been going on for years that's been wrong.
Oh, wow.
And we got to backfill a bunch of data. It's like, oops.
Oh.
And it's fine. It's all there. It's in another system, but it's just like, because we were almost done.
That's just straight up painful, man.
Yeah. And I don't think that this guy, did that necessarily, but like test code, like how do you know that your tests are complete? Like you're literally trying to prove a negative here on that. So bear that in mind. It doesn't like your test code does not get tested at the level that your app code does.
So next, rewriting private methods as public because testing is difficult. Unit tests are designed to test units of code based on basically interfaces. They don't test the particular implementation details of the code. And so private methods are implementation details that should be tested indirectly through those public interfaces.
Right. And this anti-pattern arises when a developer is trying to increase code coverage, but they're not able to test all the private methods in a class. Therefore, they start making those private methods public in order to test them. This is really not a good idea, though they're private for a reason. And typically when you promote something to public, you're adding a lot of other concerns that you don't think about. You're adding security concerns potentially for stuff overriding it. You're adding just concerns with documentation or with people calling it the wrong way.
Mm-hmm.
It's not ideal. I think the other thing too is it overcouples your test code to the thing under test, so that gets you pretty quick if you're not careful.
Yeah, if you have too many private methods associated with one public interface, or there are too many possibilities to test them all, instead of making the private methods public, consider breaking down your public method into multiple component methods.
And we've actually got a link to an article on this talking about whether you should test private methods.
Yes. Yeah, you should look this up. It's shoulditestprivatemethods.com.
I think I know what it's going to say. Yep. I will say that I have bent this rule a little bit in .NET by calling stuff using reflection on occasion, and it was mainly where there was something really weird going on, and I was trying to not unit test, but like spike and try to figure out why something was breaking, and it was hard to like debug into it. I don't recommend doing it.
Yeah. Next, anti-pattern is overuse of abstractions. It's too dry. It's like Dune. Desert planet in here. While test code is real code, it is not implementation code and shouldn't be written the same as implementation code. It's easy to get into that habit of not repeating yourself by abstracting anything that you use more than once. And that's not always the best thing to do when you're writing your test cases.
Yeah. Test code is more than just code. It's also documentation. And because it's documentation, it needs to be descriptive and easy to follow without jumping through a whole bunch of abstractions. And, really you shouldn't have to scroll much, if at all, or open multiple files to understand the unit test code. The other thing here is that, if you do dry it out too much, you end up in a situation where anytime you change something, now you've broken a whole bunch of stuff versus, hey, just this one little section. Like it doesn't have the same goal as the rest of your code.
Yeah, it really doesn't work out well here. Instead of dry test code, you want it to be damp, descriptive, and meaningful phrases. I didn't make that up. I pulled that from an article. I thought it was really cool.
I'm glad.
You'd be concerned if I made that up?
I was praying for you.
Yeah, no, I would have come up with something more interesting than damp. Anyway, actually, I think it's really good. But since the goal is to understand the test and the code you're testing, some repetition is probably necessary.
And speaking of repetition, another rule that goes along with this, multiple tests testing the same or very similar things is also an anti-pattern. If they have the same test code, but they change the values passed, but the values are the same sort of values, then it's not really a valuable test, if that makes sense. Like if you're It's one thing if you're testing like a normal input and you're testing an edge case, those may be kind of similar, but they're not. Whereas if it's, they're both normal cases or they're both edge cases, then it's kind of dodgy, I guess is the best way to put it. Like, it's hard to describe this in audio.
Mm-hmm. You're going to want to have separate test cases between the happy path the code takes and testing for errors. Yeah, this is something that, they're going to look very similar, except you're going to cause it to throw an error, but your assertions are very different too.
Yeah.
So like it's going to look very, very similar all the way up until you get to the assert stage. And that's going to look very, very different. And so you're going to want those to be separate. They're basically testing different events and outcomes. So while a lot of the setup is going to be very similar, and the act should be the exact same, your assertions will be different.
Yeah, a good way to address this issue is through the use of table-driven testing, which allows you to run the same test code with different values for each run. This reduces the duplication of test code and lets you compare different cases. So we do this a lot with, you'll have like 5 or 10 different sets of variables that you use, and it runs all of them.
Yeah.
But it's the same test code.
And that's good. I've done this where I wanted to test, well, hey, what happens if this value is missing, or this value is missing, or this value is missing? And rather than writing test cases for every one of those, I would use a table-driven design to where it was like, all right, here's an object with all the values populated. Here's one where they're missing. Here's one where like they don't make sense and stuff like that. And so it can run through and you can see what happens for each one, especially if it's supposed to like absorb or, not throw an error.
Right. Once it starts throwing exceptions, then that table gets not fun.
That becomes, well, if it's supposed to throw exceptions, if stuff is messed up, at that point you go, okay, that's a different test because you're getting a different assertion.
You can also include a type of as one of the table columns. I don't recommend doing that, although I didn't die. So, it's kind of like, I'm still, it was okay. It's just, wasn't worth the trouble.
So next is piggybacking on existing tests. On the other extreme from the multiple tests is the piggybacking, or adding assertions to existing tests to test a distinct or new feature. The more of these you add, it makes your test less descriptive because it's not testing a specific feature, a specific unit. It's just going, oh, well, since we're already in here and we've already got these tests, I'll just add an assertion here.
Yeah, or, where somebody is avoiding adding a new testing file is the one that I've seen. Where I've worked at companies that thought you ought to have this big block of crap at the top of every file telling what's in the file. And so people were resistant to creating new files. And so they would piggyback. Yeah, I mean, because it's like 15 minutes of work for, hey, I'm just making an interface that's got 4 members. Like, why can't that be in a file that doesn't have this? But that's a whole other topic. But you end up piggybacking, and if you do this long enough, your test names basically end up being like what comments end up being. They end up being lies. And as part of the code's documentation, you want your test names to be descriptive as possible and accurate as possible. And you also want to be able to run those tests in an individual fashion. So if you cram more stuff into the suite, like you've got a GUI test runner, unless they're broken out and you're like, oh, I need to run all the tests for this one thing, but it's tied to 5 other things, that's a longer test run and you're wasting everybody's time. Sorry to go into rant mode on that. It's lived there before.
Yeah, I've seen it too. So I don't disagree with you. Now, this doesn't mean that you have to create a new test case every time you make changes to the code. Like if you're adding a new method or new features, then you should create new test cases. But if you're altering functionality of an existing method, then modify the existing test to reflect that change in functionality. This is not saying don't ever change test code once it's created. No, if you're going in there and you're making changes to let's say you built something, you built a feature, and your product owner just wasn't very clear, or you gave them exactly what they asked for and they realized that's not what they wanted. They wanted it to,
Thankfully, that
be,
never happens.
yeah, they wanted it to be all caps or something. I don't know. And so you have to go back in and change your code, change your test code to reflect that. That's fine.
Yeah, my thing with that is I want to see a red before I change the test code. Like if I don't see a red, then I don't want to change it. I want to add. Most of the time, that tends to be what works for me. But
Yeah, that makes sense.
I don't know that that's necessarily the best. I would love to hear from the audience on that one.
Yeah, leave us a comment on that. That's a good discussion.
Yeah, or just shoot us an email, neckbeards@completedeveloperpodcast.com. Why not? So another thing that will get you is testing for a specific bug. Sometimes you need to reproduce a bug so that a new test case is created for reproducing that bug. A lot of times developers are less descriptive in naming these tests. They call them something like, test for bug and then the bug number, or darn thing is broken, but it wasn't darned. That was one of my favorite ones in a test suite that I inherited years ago.
Yeah. Yeah. The issue with this type of test case is that, it's not that bad in the moment, but years later, when that bug is no longer even a memory, but the test is still there, something changes in the code and that test now fails, but no one knows exactly what it was testing or why until you have to dig in there and figure it out.
Yeah, and you always find these with like validation builds and stuff too. Like you don't ever find it with like the GUI and you've got a debug capability. It's like, nope, just broke. Your build failed overnight. Sorry. So yeah, definitely be a little bit careful about how you name it and how you denote what's going on there. Most of the time these tests could be added to existing test cases that didn't cover enough area to catch a particular bug. And if a new test case does have to be created, then just name it right.
Yeah. I mean, what you want to do is name it based on the behavior it's testing. Not, it's testing this bug, but what is that? What is causing that bug? What is, what is the effect of that bug? Like it's testing that this doesn't happen or that happens. Or I don't know.
Yeah. Well, and the thing is you're testing something. You want to be your naming convention needs to be as close to the thing under test as possible, not test to make sure they didn't put a null in the database. It's like, no, when this is null, here's what I do, because maybe they didn't put it in the database. Maybe it came out of the cache by this point. Who knows? You basically want to name things in a way that the effective naming doesn't change easily.
Mm-hmm. The next one is test cases are concerned with more than one unit of code. One test to rule them all. Sorry, I couldn't help myself. Unit tests are not rings of power. One test case should not affect the others, especially not have other cases relying on it. If things change in one area, you'll have a tough time maintaining the test because you'll have multiple places that you have to make changes.
And I've seen this with like a lot of assertions that are in functions that get called by multiple tests. It's like, why did you do that?
Yeah.
Man, it may not be a test over others, but you can end up with a chain of tests if you're not careful. And you could even end up in situations where they have to be run in a certain order because one of them does something that the next one needs. And this used to be a bigger problem than it is now. But, like back in the day, it was fairly deterministic. And I think a lot of the test suite runners now are not, specifically so that you don't get there.
Yeah, that's like this had its own subpoint, I should say, had its own entry in the Stack Overflow article I was reading. But I was like, that's not really a big issue now. So it kind of fell in with this one. I was like, it's important enough to mention, but not to have its own point.
Yeah. I mean, like back in the day, people a lot of times had to write their own test runner that tested all their stuff and did the asserts, very old school. And when you did that, it was easy to get into that place. And I think that's why the test suite runners now do it in a fairly non-deterministic fashion, is so that you get burned by this before it really burns you.
Yeah. This could also be just one enormous test that covers multiple methods or processes. If the test code is more than a handful of lines, then you might consider breaking it up. And it's when tests get too big, they can start having bugs themselves,
Yeah.
testing bugs. Nobody wants a testing bug.
Yeah. I really like to think of tests as almost their own, each test is almost its own program, to simplify it and go, hey, like it really needs to be super duper isolated and small so that
Yeah.
that doesn't happen. So the next one, and this, obviously is not a small test, and that's where you test everything, including framework code or language code. Not every possible case has to be tested. At a certain point, you're reaching diminishing returns in your test cases where you actually waste time creating tests or maintaining them rather than saving yourself time by having them. A really common thing is like testing, property assignments. I see people do that all the time. It's like, what in the world? Like, do you not trust? Like, if you can't trust the framework that you're running on, how do you know your test works?
Some of these tests are testing cases so rare that they will only need to be tested if there's some type of malfunction. Others may not even impact the application if they fail, or they may cause like immediate failure and like where you don't really need a test for it, because if what you're testing goes wrong, it's going to be,
Yeah.
there's not anything you can do about it to prepare. It's like, all right, nope, that's going to have to take,
Yeah. Like my code at work, I feel like that if a massive tsunami wiped out the eastern seaboard, it's probably going to fail because I don't know how to mock that. Right. And I'm okay with that because I feel like there's another problem when we get there.
yeah, yeah, it's that kind of thing.
If you're not sure if the test is necessary, then actually sit down and do a cost benefit analysis. Look at how often it's going to be used, if something is going to change and affect that, and then look at the benefits of the test. Then look at the amount of time to write and maintain the code, including maintenance costs. If the cost is more than it should be, then you don't write that test. And some of that is you kind of do that by feel, but especially if it's either not your code or it's just a really rare circumstance that's a lot of bootstrapping to get the test up, then it may not be worth doing until you're at a point where that's the kind of thing you're testing.
Yeah. All right. So our final point we're going to talk about, our final anti-pattern, I should say. Tests require too much intimate knowledge of the code to run. Tests only need to know about the methods they're testing, and even then, only the interface, or basically what's being passed in and what's coming out. Not really the specific implementation details. This particular anti-pattern or set of anti-patterns a lot of times comes from attempts to get a 100% code coverage when that's not always realistic or even ever fully realistic, I guess. Unless you set up like it depends on how you define 100% code coverage.
Yeah. Like 70% of the time it's tested all the time.
Yeah.
And you're probably okay.
But like, it depends on how you define code coverage. Like, because if you define framework code as code to be covered, then
or
you're going to have a bad
code.
day. Yeah.
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 Or the microprocessor code.
Yeah.
Yeah. Or just math. Math and physics. I do know people that I think would honestly test physics if they could.
I know people who have tried.
Yeah. Test cases could be really innocent, right? Like it could be, you break rules about encapsulation, like knowing too much about the method you're calling, or really dangerous, like reading private fields, or even getting into private files to run. One thing that I have seen where this will get you on some occasions is stuff where you're having to mock. And that's something I haven't really got resolved in my own personal way of looking at things. It's because like I have to, to mock something thoroughly where the code, under call can use it. I have to know implementation details, and I don't know where the line is on that one. And I feel like that line still moves for me, but that's another.
Yeah. I mean, I'm trying to think about that because like I guess the way you set up your mocks, you could still have it like what goes like if you know what goes in and what goes out and the name of the method you're mocking,
Right.
that's all you really need to know, right? You don't need to know
Well,
what goes on within that method, do you?
like if you have, if you know what goes in and out, and then let's say you have a query builder pattern, and that's being constructor injected into the object you're testing. Now you have to know, okay, what does this thing call in the query builder? Because I got to give it fake data in response to a chain of calls. And like my opinion on this changes every single time I touch code like that. So it is very frustrating. And I feel like that's honestly an anti-pattern, right? Like maybe we shouldn't test the query builder, or we shouldn't mock the query builder. Maybe we should mock the data source under the query builder, so that the query builder we don't care.
Yeah.
Like maybe that's the fix. I don't know. I struggle with that one a lot, and I'm still not quite stuck on an answer. I think I'm just going to have to like smack into the wall enough to get there.
Yeah. I don't know because I haven't really run into that too much. So that's a good one. All right.
No, it didn't.
It's a tricky one, is what
Uh-huh.
I mean by it's a good one. It's a good thing to chew on. It's not a good problem to have, I suppose.
Right.
Yeah. Now back to it. This may not be a problem with the construction of test cases, but with the class being tested. So kind of going back to what you're saying, it might need to be refactored if possible to use less data hiding and fewer private fields and methods. So that's a thing to consider, especially when you're doing test driven development, is how you're constructing your classes and stuff.
Well, and I think TDD kind of gives you a bias towards not having those kind of problems because you can't test.
Right.
It's when you're backfilling testing that you get hit by this.
Yeah, that's true. Or when you're like not done TDD and you're going into TDD and you have to deal with areas that have not. Yeah. All right, guys, this is far from a comprehensive list of anti-patterns that you will find in unit tests. The ones listed here are some of the more common ones that you'll find. You can check out the link to Stack Overflow for a much larger list of patterns. Now, just like healthy design patterns, anti-patterns are not something that people set out to create, but are patterns that are noticed over time and across developers and code. Use the ones listed here to help guide you when you're writing test code so that you know what to avoid, or when you're working with someone else's code so that you can easily recognize something that may need to be refactored. Now, don't forget to check us out in the aftercast, where we'll be talking about code smells for your unit test code. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, given that it's getting close to the end of the year, a lot of people are probably thinking about their goals, right, for next year. And I would assert that a lot of the same things that you have to consider in unit testing, especially your anti-patterns, also apply to the way that you do your goals. A lot of people don't have a structure, right? They don't set things up for success. They don't actually do the thing that they're trying to do. And then they don't have a way of telling whether doing it actually helped, right? They do things like piggybacking on an existing goal, right? Like, hey, I'm going to have 2 goals this year. And one of them is going to be, I'm going to go to the gym 3 times a week. And the other goal is I'm going to be able to deadlift 500 pounds, right? Well, your second goal is essentially piggybacked off your first. So the interesting thing about the unit test anti-patterns is that most of them will apply to your personal goals as well. So when you're breaking stuff out and you're going, okay, here's what I want to do next year, see if you can actually come up with a testable unit for each of the things that you're trying to do by itself, including, okay, here's what I got to do to set it up so I can do it, right? Like if you're broke and you can't get a gym membership, then like that's not going to work. Then you're actually going to have a goal of doing the thing. And then you need to actually be able to prove that you did it, right? So it shouldn't be a goal that doesn't get you any kind of feedback. This is why we talk about the SMART goal stuff so much. This kind of all interlocks in the same way. And you'll start noticing this as you do more unit testing and as you're more goal driven. Like you realize that the mindset is kind of the same. So I just wanted to put that little bug in your ear, not to give you advice, but to give you something to chew on so that you make your own advice. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.